Okay. Here's what I'll say about base 5. In this textbook, they talk about base 5, base 6, base 4. They talk about all those things. In my mathematical experience, I have never used bases. Never. So I'm not quite sure why they are being covered, but they are, and they're on our syllabus, and so that's why we're going through there. Now, are you going to teach this to your second grade class? No. Are you going to teach this to your preschool class? No. Am I going to teach this to my college algebra class? No. But nonetheless, at some point you're going to see it, and if I had to guess, it would be on one of those standardized tests like a Praxis or your GRE or something like that, where you're trying to get into graduate school or get into an education department. So that's why we're covering it. Please do not let this break your spirit and say, oh, I hate math and so forth. You're only going to have a little bit of this. It's not going to be heavily tested on the final. You might have one or midterm. You might have one or two questions. Just do your best on it. Don't get bogged down with it. If you don't catch on really fast to it, that's okay. It's not going to make or break you. Just do your best. Okay? Now, the best way I can explain this is thinking about a clock. And a clock has nothing to do with base 5. But if you think about a clock for just a second. Let's say here's my hand on my clock. It goes around. We go 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, and then it starts back over. So 13 o'clock, which there's not such thing, except in military time, of course, but 13 o'clock is actually going to be 1 o'clock. So 13 corresponds to 1. 13 hours corresponds to 1 o'clock. And so that's how I want you to think about this 5, this base 5. If I gave you the number 6, that's actually 1, 1 in base 5. Now here's how they got that. They said, okay, I have 1 5, and then I've got one more. And so that's what made, actually it says this, I have one set of 5s, and then I have one more, and so that's what made 11 base 5 there. Now what you know about base 5 is, if it's base 5, that means every number in there is less than 5. So if you have something written in base 5, it can have a 0, a 1, a 2, a 3, or a 4. But 5 or more go away. Okay? So you can't have 5 or more. 5, 6, 7, 8, they have to be written in one of these numbers. So that's something special about base 5. Now I'm only going to ask you on your test, your quiz, your homework, there may be one base 6 in there that you have to figure out, but the majority of the ones I'm going to give you are base 5. I ask it 3 different ways. Okay, I ask you to take something in base 5, and this is your notation right here if it's in base 5, and I ask you to write it in base 10, which is a normal, our normal numbers. So I'm going to ask you to write from base 5 into the normals. There's another one to practice. I'm also going to ask you to write a normal number. And the reason you'll see it's normal, it doesn't have the word 5 written as a subscript. So that's how you know this is a normal number. So we'll go backwards and write a normal number in base 5. Got 2 of those. And then I'll ask you to add them. So those are going to be your 3 objectives with the bases. Okay. Now remember earlier where I made you, let me see if I can go back. I made you write out this in expanded notation, and in our traditional numbering system, this would be 10 to the 0, 10 to the 1, 10 to the 2, and 10 to the 3. That's exactly how you're going to do the 5s, except it's going to be 5 to the 0, 5 to the 1, 5 to the 2, and 5 to the 3. Okay? So if I look at this one, I've got 3, 2, 1, and 4. Okay, 4 is in my units position. So this is going to be 4. Let me write it here. Oh, hit the wrong button, sorry. Well, no, let's go. This is going to be 5 to the 0, and this is going to be 5 to the 1, 5 to the 2, and 5 to the 3. So if you wrote this in expanded notation, you're going to have 3 times 5 to the 3 plus 2 times 5 to the 2 plus 1 times 5 to the 1 plus 4 times 5 to the 0, which is the exact way that we did our expanded notation earlier. Now remember that 5 to the 0 is 1, so this piece right here would be 4 times 5 to the 0 is 1. Okay, this piece right here is 1 times 5. This piece right here, 5 squared. Okay, refreshing your memory, 5 squared means 2 of those, which would be 25. 5 cubed would be 1, 2, 3 of those. And if you multiply that out, you get 125. Now, so that's how you're going to start one of those that I ask you to write in base 10. You'll just break it into its expanded part. Okay, so 125 times 3. I'm going to get 375. 2 times 25, I think of those like quarters. 2 quarters would be 50. 5 and 4. Okay, so I'm going to add 375. 50 plus 5 plus 4 would be 59. I'm going to add them up. Now I'm writing this as a regular number, so since I'm writing this as a regular number, it does not need a subscript. Okay, so the difference again when you're writing in base 5, if you're writing in base 5, it needs to have 5 written below it like this. If it doesn't have a subscript, you know it's understood to be regular base there. Okay, so let's do one more of these. Okay, if I ask you to write 413 in base 10, right now it's in base 5. Remember, this is 5 to the 0, this is 5 to the 1, and this is 5 to the 2. We just step it up. So I'm going to have 4 times 5 squared, that's the first one. 1 times 5 to the 1, that's the second column, and 3 times 5 to the 0. Okay, remember 5 to the 0 is just 1. I almost forgot it there. There we go. 5 to the 0 is just 1. Anything to the 0 power is 1. In the middle, that's just 1 times 5. 5 to the 1 is 5. Remember 5 squared from the previous slide is 25. Okay, if I take 25 4 times, that gives me 100. Plus 5 plus 3 would be 153, and that's how it would look in base 10. Now then, somebody's yelling at the screen. It's not 153, is it? It's not 153. What was I thinking? So you have 100, and then you have 5 plus 3. You don't have a 50 in there, so if you put that in there, you get 108. Sorry about that. 5 plus 3 is just 8. So if you added 100 plus 8, you'd get 108. And so that's how your answer should be. Okay, it's probably as long as that video needs to be, so we'll make a new video for the second part.